of reversible processes, irreversible processes, then equivalence of second law of thermodynamics, then difference in between reversible process and irreversible process, then Carnot theorem. Then also we have gone for the Carnot theorems, Carnot cycle, how to calculate the efficiency of Carnot cycle, and we come to know that efficiency of Carnot cycle is based on the all reversible processes, in which two are isothermal processes and two are isentropic processes. And efficiency of Carnot cycle is depends on temperature. So two temperatures are there. One is heat addition temperature and another is heat rejection temperature. So on which the efficiency of Carnot cycle depends. Then Carnot theorems also we have discussed, and equivalence of second law of thermodynamics. And then we have started to solve the numericals on the heat engine, heat pump, refrigerator, and Carnot refrigerator and Carnot heat engine. I think this numerical is on screen to determine the heat to be supplied to a Carnot engine operating between 400 degrees Celsius and 15 degrees Celsius and producing 200 kilojoule of work. So I think this numerical we have completed. Okay. So Carnot cycle efficiency is function of temperature. That base we are taking for solving this numerical. Then I think also we have discussed or solved this numerical. So a practice numerical based on the previous numerical also given for you to solve. Then this numerical of domestic refrigerator meant that two temperatures are given, and leakage, assuming leakage of heat, that is Q2 is given, and we have to calculate the power required. I think up to these two numerical we have covered. Correct, na? Up to these two numerical, and we have to now solve more numericals on our from our exam point of view. Now one numerical. Okay, Prashant Mari. So don't chit chat anything like odd things. So another numerical on your screen is, now you have to solve. A Carnot engine works between temperature limit of 825 degrees Celsius and 125 degrees Celsius. The engine receives 3600 kilojoule of heat per minute. Determine power of the engine and amount of heat rejected to sink per second. So this is a 7 marks numerical is there, and asked for April 2016. So I request all of you to try for this. It is a Carnot engine. So try for it and get the solution. Carnot engine works between temperature limits. So two temperatures are given. So as two temperatures are given, we can calculate the efficiency of Carnot cycle. And engine receives, so whatever the engine is receiving, the heat from source, they are given per minute, and we have to calculate the power. So I think two formulas are with us. One is of Carnot cycle and another is any general heat engine, how to calculate the efficiency. So we have to use this formula and we have to calculate the these two parameters. Now I request all of you to drop tell your answer or in message box. Solve it. I will give 3-4 minutes, 5 minutes times to you. And if you are not solving, then definitely I have to intervene. So I request everybody, Suhas, Ajit, all of you to start solving the numerical. So Carnot engine works between temperature limit of 825 degrees Celsius and 125 degrees Celsius. So two temperatures are given. one can find out easily efficiency of engine if these two temperatures are known. So a temperature, convert these temperatures into Kelvin first and find out the efficiency. And efficiency is also equal to the heat interaction ratio, heat interaction. With the help of that, we can calculate the Q2, and after Q2 or W also we can calculate. Let's try. Formula is last lecture I told you. So write down the numerical on your notebook. The Carnot engine works between temperature limit of 825 degrees Celsius. So T1 is equal to 825. So I request all of you, I will now stop 5 minutes. So anybody solving, anybody getting answer? Are you solving or am I audible na Suhas? Hello?
Sir, yes, sir, audible.
Or are you solving?
Yes,
Trying to solve?
trying solo.
Attempt getting solution? Shall I wait or I start giving solution?
Wait, sir.
I have to start solution.
Yes, you can start, sir.
No solving, nobody is trying to attempt. Okay, so let us know. Now this is a Carnot engine, so definitely when numerically there we have to draw the schematic for this. So Carnot heat engine is there. So Carnot heat engine is there. Therefore, draw the source. Okay, source at temperature T1. So heat engine is the source at temperature T1. This T1 is equal to, or this T1 value is there equal to now 825 plus 273. So this is the value of T1. So it will be 870, 825. We have to write like this plus 273. Okay. So somebody can calculate it and tell me what is value, T1 value on unbalanced scale. So it is 8 T1 value. So conversion is required in Kelvin. Okay. So from this T1, heat is taken. Okay, let us consider this heat as Q1. Okay, so this heat is given to the Carnot heat engine. So we'll write this as a Carnot heat engine. We'll draw. Okay, and this is our heat engine. What is purpose of heat engine? To develop the work. So this will be developing work W. Okay. So I think okay. Somebody are calculating. So here, so Q1 W is there, and at the same time, it is rejecting some amount of heat Q2 to the sink at temperature 125 degrees Celsius. So it will be what? T2 is a sink, means low temperature as a sink, so is equal to 125 plus 273 is equal to, somebody can help, I think 390 398 Kelvin. It is T2 temperature is given. Okay. The T1 may be I think 10 1098 Kelvin. So these two temperatures were having. Now the engine receives 3600. So here what we can say, Q1 is equal to, receives means what is the engine is receiving Q1 amount of heat, and what is the value? 3600 kilojoule of heat per minute. So 3600, okay, it is kilojoule per minute. So it will be what? 60 seconds. So it will be what? 30 kilojoule per second, because 1 minute is equal to 60 seconds. So we have to divide it by 60. Therefore, it is equal to how much? Is equal to this we get cancelled, and we will be getting 60 kilowatt is the 60 kilowatt is the Q1. And they asked to calculate. What they asked to calculate? They asked to calculate here, determine the power engine. Power means work required. What is work required? So here first of all, we have to calculate the efficiency of Carnot engine. As it is engine, so ETA engine, Carnot engine will be as a function of temperature. What is function of temperature? So is equal to T1 minus T2. T1 minus T2 divided by T1. And this will be efficiency formula. What is formula is coming as? So here it will be 1098 minus 398 divided by T1 1098. So it is coming as, efficiency is coming as, anybody? Efficiency is coming as, anybody? Or nobody calculated? Efficiency is coming as point, okay, correct, 0.637. Okay, but this efficiency, now I will go to next slide. So this efficiency is equal to 0.637. So this 0.367 is the efficiency, is also equal to, what is formula for efficiency? Formula is equal to W, input divided by output by input. So here W or power divided by input is Q1. Okay, and in this case, power or W is equal to, in that case, 0.637 into Q1 is of 60 kilowatt. and I think answer will be, in that case I think many student I think got, so 38.25 kilowatt. This is the answer. So this way we have to solve the numerical. So after getting efficiency, we have to write here efficiency is a function of temperature, and after that we have to we got efficiency. So this efficiency, Carnot engine is also a general heat engine. Therefore, its efficiency is also equal to work obtained from the engine divided by heat supply. In that case, W or Q means it is nothing but Q1 is nothing but Q1 minus Q2, but Q1 minus Q2 is equal to W. If you see that here diagram, Q1 minus Q2 is equal to W. Incoming is equal to outgoing, that way. So Q1 is incoming, outgoing is W plus Q2, and therefore Q1 minus Q2 is equal to W. So this is the correct answer. W is equal to 38.25 kilowatt. Shall I proceed for next numerical?
Yes, sir.
Shall I proceed? Okay. Okay. Before that, a very simple. Okay. Now here is numerical for you. A refrigeration plant for food store operates as a reversed Carnot heat engine cycle. The store is to be maintained. The store is to be maintained at a temperature of minus 5 degrees Celsius, and the heat transfer from the store to the cycle is at the rate of 5 kilowatt. The store is if the heat is transferred from the cycle to the atmosphere at a temperature of 25 degrees Celsius, calculate the power required to drive the plant. So again, refrigeration work on reverse Carnot. Reverse Carnot means what? Its efficiency, sorry, its COP is a function of temperature. Its COP is a function of temperature. Okay. So now I think refrigeration plant for a food store operates as a reversed Carnot engine cycle. Means they are given the COP of this numerical is based on the temperature. The store is to be maintained at a temperature of minus 5 degrees Celsius. So sink temperature for this is given as minus 5 degrees Celsius, and heat transfer from the store to the cycle is at the rate of 5 kilowatts. So Q2 is given. If the heat transferred from cycle to the atmosphere at a temperature of 25 degrees Celsius, calculate the power required to drive the plant. So 25 is the temperature of source Q1. So first of all, we can find out COP of Carnot refrigerator or reversed Carnot refrigerator, and in terms of temperature we will get. Afterwards, same formula we have to write for the in terms of heat interaction. That is Q2 divided by W, and we can Q2 is given, W we have to calculate. Similar numerical of previous, only here there in Carnot engine was given, and here Carnot refrigerator is given. So try Shubham, trying Shubham Gandole. Now it is clear. What is clear? Shubham. Shubham. Hello, Shubham.
Yes, sir. Yes, sir. Yes, sir.
Now solve it. Okay, shall I give 5 minutes to you all? Hello. Shall I give 5 minutes? Anybody is attempting or I have to solve? If anybody solving, Soha, Ajit Gaikwad, Kunal Chete, Kunal, trying sir, okay. Shall I wait or shall I go ahead for the solution? Ajit Gaikwad, sir, you solve this problem. Okay, you are not trying. Okay, I am trying. You are trying. Ajit is trying, but still asking to solve. Okay. Again, I will wait for 1 minute and I will give solution. Voice is breaking.
Sir, voice is breaking.
Okay. Now also breaking. Okay.
Now, okay, sir.
Let's start solving so that in between those we'll get answers. They can mention answers like previous numerical in chat box. Okay. So this is our Carnot refrigerator. Okay. So this is a refrigerator work given. So in our case, we are writing this work like this. So sorry. So in our case, we are drawing like this W. Okay. Then there is some books they are given it as a W. Okay. As it is arrow is towards outside, therefore, sorry, you are giving this is a refrigerator, therefore arrow is towards W. That is W is supplied. Okay. Now here, see engine. This is Carnot cycle, Carnot refrigerator. Its COP is function of temperature. Now, two temperatures are given. So one we know that one is -5 degrees Celsius, which is sink temperature. So this is a sink temperature -5 degrees Celsius, and source temperature where heat is rejected, it is source temperature. It is 25 degrees Celsius. So here, 25 degrees Celsius means we consider it as a 25 plus 293. 273 is coming as 298 Kelvin. So T1 is coming as 298 Kelvin. T2 will be equal to what? T is equal to -5 plus 273 and it will become 268. So two temperatures we know. Therefore, COP of refrigerator is nothing but what? Function of two temperatures. What is formula now? COP of refrigerator? We can put in our temperature here. First of case, COP of refrigerator is nothing but here temperature now T2. It is a temperature T2 divided by T1 minus T2. So everybody is writing numerical in notebook. So T2 divided by T1 minus 2. And in that case, T2 is given. What is T2? 268. T1 is 298 and T2 is again 260. So COP of our refrigerator, Carnot refrigerator is coming at what? 8.93. Okay. Now here again COP is what? function of refrigerator is also function of what? Heat interaction. Only for Carnot refrigerator or possible reverse Carnot refrigerator, here this is going to be the function of temperature. Otherwise, in general, the COP is a function of heat interaction or work and heat interaction. So COP is equal to output of the refrigerator is always here. Sorry, amount of heat to be extracted, Q2, amount of heat to be extracted, that is Q2, divided by how much work is supplied. Okay. Now this is Q1. Now in this notation they have given Q1. But in our case it is going to be what? Q2 is there. And this we are considering as a our notation is Q1. So Q2 is equal to 5 kilowatt. Already is given. Therefore it is 5 kilowatt divided by W. What is W they have given? Here W they have given as a here W they have to calculate. We have to calculate. So W is COP, but COP we are what is COP value? 8.933. Therefore 8.93 is equal to this Q2 is 5 kilowatt divided by W, or W means power. If it is a kilowatt, we are considering it as a power. Work or power is going to be same. Rate of doing work, we call it as a power. W is equal to 5 divided by 8.99933, and it's coming as what? 0.56 kilowatt. 0.56 kilowatt. So nobody solved. Okay. Now same numerical I will give for practice purpose. Okay. So storage is to be maintained at -10 degrees Celsius. Now everybody I request to solve. And heat rate is also here 8 kilowatt. 8 kilowatt. And temperature will be 35 degrees Celsius. With these changes, I request all of you to solve. A refrigeration plant for a full storage operates as a reversed Carnot heat engine cycle. Means it is reversed Carnot cycle means refrigerator or heat pump. And engine cycle, Carnot cycle means used for engine. And reversed Carnot cycle used for heat pump or refrigerator. Now with these changes, I request you, because nobody has solved previously, let us practice for this. Write this numerical in your notebook and try to solve again. So 1.36. So Shubham, it is the answer of previous this numerical only. Shubham? Yes, sir, okay. This answer Shubham got it as a 1.36. Okay. So after doing the changes, answer is going to be 1.36 kilowatt. Good. Bala, this is 1.36 kilowatt. Ajit Guy 1.36 kilowatt. Okay, nice. Suhas is not there today. Suhas is not solving. Suhas, are you solving? Are we in class? Huh?
Sorry, sir.
I am not finding the answer on screen. So 1.36. Okay. Shall I consider this as the correct answer? Not required. Not required to solve. Not required, na? So Ajit, Balaji, other people, girl side, nobody
Yes.
is calculating. Shall I proceed to next numerical or I have to solve? Okay, next. Gaurav Kondi is giving order to us that we have to go to next numerical. Okay, now little bit complicated numerical. Okay. So heat engine is used next numerical. A heat engine is used to drive a heat pump. A heat engine is used to drive a heat pump. The heat transfer from the heat engine, and from the heat pump are used to heat the water circulating through radiators of a building. The efficiency of heat engine is 27% and the COP of heat pump is 4. Evaluate evaluate the ratio of heat transfer to the heat transfer of ratio of the heat transfer to the circulating water to the heat transfer to the engine. No, anybody solving? I have to solve or you are going to solve? Okay, so I will try. Well, because okay, now what is there that heat? Okay, so heat engine is there.
Sir,
It is
problem is
having
not written.
temperature. Hello, solving.
Problem is not written now, sir.
Not written. Okay, sorry. Solve. Try. After writing, draw a message that so go for solution like that. Okay, or shall I go for the solution? Return numerical return. Somebody can reply.
Yes, sir.
Okay. Now, what is telling us that? So this is a heat engine. Okay, it's having temperature. Source temperature is T1. Okay, and fin temperature is going to be T2. Okay, and this engine is receiving Q1 amount of heat from its source T1 and developing W amount of work and rejecting Q2 amount of work to the sink at temperature T2. Okay. Now this heat engine is giving this work W to the heat pump. Okay. Whatever the heat work generated, it is given to the heat pump. And this heat pump, what is operating between the source same temperature of engine, okay, and another temperature load is T3. So this heat pump is taking Q3 amount of heat, okay, and rejecting Q4 amount of heat to the source, to the sink of that source of that heat means sink of that heat engine. Okay. Now what they asked is here we have to calculate. So heat engine is used to drive the heat pump. Heat transfer from the heat engine and from the heat pump are used to heat the water circulating through the radiators of building. The efficiency of the heat engine is 27% and COP of the heat pump is 4. Evaluate the ratio of heat transfer to the circulating water to the heat transfer to the heat engine. So heat transfer to the heat engine is what? Q1. We have to calculate what? Q1. It means ratio we have to calculate what? Q1 and how much it is here used to heat the radiator. So heat engine rejected and heat pump supply. So this Q2 plus Q4. So what we have to calculate is, so this Q2 in this numerical now, Q2 plus Q4, that is amount of heat to be supplied to the radiator. This is Q2 plus Q4 is the amount of heat to be supplied to the radiator divided by ratio means to the heat supplied to the engine, that is Q1. So this ratio we have to find out. This ratio we have to find out. And what they have given? Engine efficiency of engine they have given and COP of it they have given. And from this we have to calculate Q2 plus Q4 divided by Q1. That they asked. So this is our radiator is there and it is going to be heated by heat engine sink, heat engine by rejected heat Q2 and heat pump supplied heat Q4. So this Q2 plus Q4 divided by Q1 we have to calculate. Now we'll go by one. Now, efficiency of heat engine is given by what is formula? It is going to be 1 minus eta heat engine 1 Q1 minus Q2 divided by Q1 or 1 minus Q2 upon Q1. And this is given as how much? 0.20. So this is given in the numerical. So heat engine efficiency is what? 27%. So it is eta heat engine is given as 20.27 or 27% means 0.27. Then here it is 27. Then therefore Q2 upon Q1 will be equal to 1 minus 0.27 and is equal to Q2 upon Q1 is coming as what? 0.73. Or therefore we can say Q2 is equal to 0.73 Q1. So this is equation number 1. Let us consider this as equation number 1. Okay. But from the engine now, if for the engine, W is equal to incoming is equal to outgoing. So what we can write in by first law formula, incoming is equal to Q1, okay, is equal to W plus Q2. Therefore, W is equal to what you can say, right? Q1 minus Q2 and is equal to 0.27 Q1. So Q1 is how much is there? Q1 is Q1 minus Q2 is equal to 0.27. So this W Q1 minus Q2 is equal to Q1 is 0.73 Q1. Therefore, Q2 means 1 Q minus 0.73 Q1 is equal to 0.27 Q1. So answer for W. But then for heat pump, what is for heat pump? This is a W. Okay, for heat pump, again COP is 4. What is formula for COP of heat pump now? COP of heat pump is equal to, buddy, COP of heat pump is equal to amount of heat supplied, that is Q4. Amount of supplied to the their source is Q4. Now Q4 divided by how much amount of work is supplied, that is W. So COP of the heat pump is equal to here HP. We are interested in the supplied heat, Q4 divided by W. Therefore COP of it is equal to Q4 divided by W is equal to 4, and therefore Q4 is equal to 4W, but W is equal to 0.27 Q1. Therefore Q4 is coming at 1.08 Q1. 1.08 Q1. So we got one answer Q4. Okay, Q1 also we got answer. Now we have to calculate Q2. Okay. What Q2? Q2 is equal to the here. Q2 is equal to Q1 minus W. So Q2 is equal to Q2 is equal to W Q1 minus W. So here is equal to what? We can add here another step. So Q2 is equal to Q1 minus W. Oh, sorry, it is a given. We have got it here. 0.73 Q1. So let's forget. So 0.73 Q1, 0.73 plus Q in terms of Q1, 1.0. So 0.73 plus 1.08 is equal to 1.81 Q1. So Q2 plus Q4 is coming as 1.81 Q1. And 1.81 Q1, we are requested for this. We have to calculate this Q2 plus Q4. So therefore Q2 plus Q4 is 1.81 divided by Q1 is Q1. 1.81 Q1 divided by Q1, and the answer is coming as 1.81. So this way they are asking the answer. So such kind of numerical they may ask for 4 to 5 marks. Done. Answer written. Hello, answer written. Solution written. Noted.
No, sir.
Right. You want to note down, na? Note down. Okay. Shubham, noting or what you want? No, sir means? Shubham. Okay, now next numerical. Now this numerical is asked for 7 marks on the examination. Now, heat engine receives reversibly 420 kilojoule per cycle of heat from a source 327 degrees Celsius and rejected it reversibly to sink at 27 degrees Celsius. There is no other heat transfer. Show which of the following cases the cycle is irreversible, reversible, and impossible. So first case is there, 210 kilojoule per cycle is rejected. Second case, 105 kilojoule per cycle is rejected. Third case, 315 kilojoule per cycle is rejected. Go for solution. Okay, I will solve now. I will try. Okay. Anybody is trying solve? Anybody? Okay. So I will try. And next practice numerical I will give you for you. So, but I have to. I want some answers from your side. So now show that now here heat transfer and temperature, heat interaction and temperature ratio, if you, heat and temperature if you are knowing, then any principle is there, any formula is there which can give whether the cycle is reversible, irreversible, or impossible. Anybody? Last lecture, okay, last previous lecture we have discussed one theorem or one principle, and it tells us that which cycle is reversible, which cycle is irreversible, and in which case cycle is impossible. So which theorem we have discussed? Which principle we have discussed? Anybody?
Clauses inequality.
Clausius inequality. What is that? Anybody tell? You can tell now Clausius inequality. Okay, so what is Clausius inequality? Cyclic integral. This is symbol of cyclic integral dq by t. If it is equal to 0, then what is we can say cycle is? Anybody? Anybody?
Reversible.
Huh? Reversible. So here we have tried write down your note after write whole numerical. So cyclic integral of dq by t is equal to cycle will be reversible. Okay. Then if cyclic integral of dq by t is less than 0, then cycle is anybody? Cyclic integral of dq by t is less than 0, its cycle will be anybody can unmute?
Irreversible.
Irreversible, correct. And if cyclic integral of dq by t is coming as greater than 0, then cycle is somebody can impossible. Okay. So if cyclic integral of dq by t is equal to 0, cycle is reversible. If cyclic integral of dq by t is less than 0, cycle is irreversible. And if cyclic integral of dq by t is greater than 0, here cycle is impossible. So that everybody knows. Okay. Then they have given the condition. This is fixed condition. That is, heat engine receives 420 kilojoule per cycle of heat from a source of 327 degrees Celsius, and rejection temperature is given. But in different first case, heat rejected is 210. Second case, heat rejected is 105. And third case, heat rejected is 315. Now, this applied heat is same for all cases. Temperatures of source and sink is also same for all cases. Only heat rejections are different. Okay. Now, in each case, we have to calculate cyclic integral of dq by t. Now, first case, what will draw on my one engine? If you draw, let us consider temperature is T1. Okay. Heat supplied is what? Q1. Okay. It is heat engine. Okay, developing W amount of work. Okay, rejecting Q2 amount of work and supplying to the sink at temperature T2. This is general diagram, cyclic diagram of heat engine. Okay. Now cyclic integral we have to find out what is cyclic integral of first case. We'll go for first case. Case one. Case one. What is case one? Case one is what? 210 kilojoule of cycle kilojoule per cycle is rejected. So 210 we can write here. 210 kilojoule per cycle is rejected. Okay. Now, but here Q1 is same for same. So what is cyclic integral of dq by? We have to find out. So in this first case, cyclic integral of dq by t. What is cyclic integral of dq by t? Who will tell? In this for this engine, always heat supply, dT supply heat divided by anybody temperature T1, okay, minus Q2 divided by T2. Okay, so cyclic integral of this for this numeric will be here Q1 divided by T1 minus Q2 divided by 2. Okay, and T1 is given now. What is T1 temperature? Applied at this heat is Q1 is given and T1 is given. For all cases, this will remain same. T2 here which T1, T2 and Q1 remain same. Only Q2 is going to be changed. Okay, so for 327 means what? 327 plus 273 is what T1. Okay, 327 plus our 273 is equal to I think 400 Kelvin. And second is what? 27. So 27 means here 27 plus 273. 300 Kelvin T2. And T1 Q1 is given already 420 kilojoule per cycle. Common. So this will be equal to what? Here in this case. So 420 we can consider as 420 divided by T. What is T1? 400 minus Q2 is how much? Q2 first here case 1 Q2 is different in all cases, therefore 20 divided by what is T2? 300. And what is the answer? Anybody can give answer now? So 1 point, anybody answer? 0. So the answer is a 0. So this is a cyclic integral dq by t for first case is coming as here 0. Then okay, Ajit. Okay, so what is cycle now? For this numerical cycle will be what? Anybody? Cyclic integral of dq by t is coming as 0. Then first case cycle will be
Reversible.
reversible. Correct. So first case cycle will be reversible. Okay. Now same thing you can do for case 2 now. Case 2 what will be there? Again same case, only case 2. Here let us Q1 is same, Q1 is same, Q2 is same, only Q2 is changed. What is Q2 value for second case? 105 kilojoule of heat is rejected. So Q2 is equal to what? 105. Then again similar case, find out cyclic integral of dq by t. Find out Anybody? Point Kunal City. 0.35. So therefore correct. 0.35. Therefore cycle will be already written. What is impossible? And find out Kunal for third case. Cycle will be impossible. Okay. Then case 3. Only Q1 T1 same, Q2 only got replace 105. In third case. The case third is there. Case 3. So case 3 will be okay. Okay. My here cycle dq by t. And Q3 given as how much Q3 there? Q3 value. So Q3 is how much? 315 kilojoule. Q3 is coming as what? 315 kilojoule. Find out it. Its answer is coming as anybody other than Kunal answer what? Minus 35. Minus point. Adil Gaikwad, case 3 or case 2, write down. That is case 3, case 1, case 2. Therefore, I can understand. So, this is the answer. So, first case, cyclic integral of dq by t is coming as 0. Cycle will be reversible. Okay, Adil is again saying that case 3, okay, minus point irreversible. So, write down case 3, my answer d cycle minus 30 minus 0.35 and cycle is irreversible. That also is required. Like Kunal has replied good way. Good. It is not written case but answer and impossible or possible. Now, shall we go for similar numerical? 3 times this numerical asked. Okay. Shall we go or I have to wait? Others are doing calculation, noting down. Are you noting down? So what happened today? You are not giving answer.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Ajit Gaikwad, noting down now. Shall I wait for?
Yes, sir. Noting down.
Okay. Okay. Can I proceed for practice numerical for this type? Take. Go before that. This is a practice numerical for this earlier numerical. So this numerical asked for 2 or 4 times, 3 times. This that numerical earlier numerical was also asked for 2 times. I have forgotten to mention the university years. Now here this is the case 1130 same numerical 1130 kilojoule of heat is supplied to engine from source 292 degrees Celsius. The engine rejects heat basic at 12 degrees Celsius, for which the following cases the cycle is irreversible, reversible, and impossible results. This is case 1, case 2, and case 3. So I want this answer. This is reversible, irreversible, or impossible. 5 minutes will be given to you. Are you solving? Anybody got first case? Write down numerical complete because it asked for 2 times and solve it. Okay, chronology give answer now. First one is impossible. 1.01 first case impossible, -1 irreversible, and third case is 0 reversible. Answer according to Kunal. It is here cyclic integral. I am writing Kunal's answer here. Cyclic integral of dq by t is coming as 1.0, okay, and this is equal to what? Cycle will be greater than 0. As it is greater than 0, therefore cycle is impossible. First case. Promote 1.01 impossible, -1 reverse. Correct. So then second is what? It is equal to -1, therefore cycle is irreversible. Then last is 0, the cycle is reversible. Okay, so I'm getting answers from Kunal, matching Pramod, Avkar, then Rushikesh Deshmukh, also matching answers. Okay, so cyclic integral of dq by t 1.01 greater than 0 impossible, -1 irreversible, 0 reversible. Anybody? Swaz. Now, Swaz first answer. Good. Congratulations. Great. Good, good. -1. Same answer. Matching. Rahul K. It is no problem. 1.01 -1 reverse. Others are noting down. Cyclic integral we have to find out. In each case, find out cyclic integral that we can understand. Impossible, irreversible, reversible. Good. Subham. Chaneshwar, you are getting same answers. Okay. Shall we proceed for next then? Pramod Mali. 1.01 -1. Prashant Mali. Ajit Gaikwad. Answer for matching. We will proceed for next numerical. Now, it's also asked for 7 marks in of the examination. Write down the numerical. A reversible engine receives heat from two constant temperature sources at 870 Kelvin and 580 Kelvin. It rejects 3000 kilojoule per minute to a sink at 290 Kelvin. The engine develops 85 kilowatt. Determine the heat supplied by each source and efficiency engine. Write down and think. Written. Example written. Somebody can reply so that I can understand that you are numerically over. I have to give the solution.
Written, sir.
Somebody can. Okay. Okay. Now concentrate. Now reversible heat engine receives heat from two constant temperature sources. So here source is not one. Here source are two, 870 Kelvin and 580 Kelvin, and rejects to a sink at 290 Kelvin. So there are three thermal reservoirs. One is 870 Kelvin, another is 580 Kelvin, and third one is 290 Kelvin. And this engine is interacting with all these three reservoirs: 70 Kelvin, 580 Kelvin, and 290 Kelvin. Out of three reservoirs, it is receiving heat from 870 Kelvin, 580 Kelvin, okay, and rejecting to here 290 Kelvin. And at the same time, rejecting rate is also given Okay, and developing heat, work developed by engine is also given. Shall we go for schematic now? Usually, here we can say that it is one temperature reservoir. Let us consider this as one first reservoir. Okay, T1. Let us consider this as a air reservoir is T1. Okay, what is its temperature? 870 Kelvin. Okay, then another reservoir is, let us consider this as a 580 Kelvin. Let us consider T2. Then now here 3 means temperature reservoirs will be now T1, T2 and 3 T3. Out of that, two reservoirs are there. First two reservoirs are sources and third reservoir is sink. So T2 is coming as how much? It is 580 Kelvin. So T1 is 870, T2 is 580 Kelvin. Up till now, we have discussed only one source and only one sink. Here we are having two sources and one sink. So this reservoir, so this is we consider here one engine. We will consider this as a heat engine HE. But which is this is what? Heat engine, reversible heat engine. That we have to underline. So this is the heat engine is reversible heat engine. Okay. And now it is receiving. Let us consider Q1 amount of heat from the reservoir at T1 degrees, T1 Kelvin, T1, and also it is taking Q2 amount of heat because it also supplied. Therefore, these heats are supplied. Okay, and now one reservoir is at 290 Kelvin. What happens with the 290 Kelvin reservoir? It is 290 Kelvin is let us say this as T3 now. Nomenclature will be now changed. Sink nomenclature. Previous numerical we will consider it as a T2. T2 here acts as a source. Therefore, here T3 is equal to because heat is rejected. T3 is equal to how much T3 is there? Here 290 Kelvin. But here heat rejected. Let us consider now T1 Q1, T2 Q2. Let us for T3 heat rejected will be Q3. How much Q3 is there? 3000 kilojoule per minute. So here we have to convert into kilowatt. So 3000, okay, divided by 60 kilo minute means is equal to anybody here will get cancelled. So 50 kilowatt kilojoule per 50 kilowatt is the Q3. Okay, no problem up till now. So Q1 we got Q1. Now what is one? And engine is developing. What is that engine is developing? How much work is developed by engine? It is 85 kilowatt. So let us consider here work arrow towards outside means engine work is developed and this work developed is equal to W and is equal to how much? 85 kilowatt. So this is our diagram, schematic diagram. Everybody understand? Reply me. Somebody can reply. Hello. Ajit, Kunal, anybody can reply. Unmute. Understood? Or shall I explain again?
Yes. Yes, sir.
Understand, na?
Understand, sir.
Okay. Now, have noted down. 2 minutes I will give to note down. Note down. The schematic you draw and note down. Write in your notebook. Now we have to calculate what? Determine the heat supplied by each source. What we have to calculate? Q1 and Q2. What do we have to calculate here? I will write now. We have to calculate what? Q1 is question mark. Q2 also we have to mark as a question mark. And determine heat supplied by each source and efficiency and eta heat engine. So eta heat engine. How to calculate eta heat engine? Eta heat engine is equal to what? Work obtained. Output is work W divided by heat supplied. Total heat supplied I will write. Means I have to calculate total heat supplied. Total heat supplied. And is equal to what is now W already we are knowing, and total heat supplied. Now who will be total heat supplied to the engine? Somebody can unmute and tell. Total heat supply will be anybody? Total heat supplied will be anybody? Let the answer be wrong. Huh? Total heat supplied.
Q1 plus Q2 plus Q2.
Q1 plus Q2. Correct. Because what both one heat engine is giving Q1 amount of heat supplied. Another heating is another reservoir is giving Q2 amount of heat. Therefore, this will become Q1 plus Q2. That way we have to calculate the efficiency. But for this, both calculations, for calculating both things, we need Q1, Q2, and here also we need Q1 and Q2. Here W is knowing. Okay. Now we have to calculate. Now, as engine is reversible, what is our law? Principle by Clausius inequality. Write down. So write with me. So by Clausius inequality, by Clausius inequality for reversible cycle or here for reversible cycle. Who will tell for reversible cycle what is Clausius equality? Anybody? Cyclic integral of dq by t is equal to anybody? Cyclic integral dq by t is equal to
0.
0. Okay. Now who will tell cyclic integral of dq by t for this solution, this case, 3 reservoir case? 3 reservoir case. Who will give the answer? Cyclic integral of dq by t. Answer who will give? Therefore, what equation will get now? First reservoir, thermal reservoir, temperature T1, heat supplied is Q1. Therefore, who will help me? Q1 divided by, somebody can unmute and tell. I can get Q1 plus Q1 divided by T1 plus another reservoir which is at temperature T2, and here amount heat transfer is Q2. So what will be there? Q2 divided by T2 plus, or shall I directly write minus? Why minus? Anybody? Anybody? Why minus? Because it is
It is rejected.
Therefore, minus Q3 divided by T3 is equal to, what is equal to? This will be equal to, it will be equal to 0, because cycle is, engine is reversible. They have given that reversible heat engine. Okay. Therefore, we can write now equation. Now Q1 we are knowing. What is Q1? Is how much? 870 Kelvin. So Q1 is not knowing. Temperature we are knowing. So Q1 we are knowing, that we have to calculate Q1 divided by temperature is 870 Kelvin, plus Q2 also we are not knowing. What is temperature of Q2? 580. Minus Q3. Q3 we are knowing. What is value of Q3? Is 50 kilowatt. 50. So answer will get in kilowatt, because Q1 and Q2, Q3 is in kilowatt. 290 is equal to 0. This implies that. Will be imply that. So let us 290 divide, multiply by 290 LHS or and RHS side, multiplying by 290. What will get? Multiplying by 290. Anybody? Equation will get after multiplication by 290.
Q1 upon
3Q1. 3Q1, correct na?
No, sir.
3Q1 multiply. 3Q1 plus Q1 upon 3. Okay, sorry.
Q1 upon 3.
Q1 upon 3. Q1 upon 3 plus Q2 upon
2.
Minus 50.
Yes, sir.
Correct na?
Yes,
Is equal to 0. So one equation we are getting here. One simultaneous equation, one equation we are getting. What is that equation? So 2Q1 plus 3Q2. 2Q1 plus 3Q2 is equal to, so this 50 I will transfer this side. It will become plus 50 and multiply by anybody. 3 into 6. 6 into 50. Correct? 300, na? So this is equation number 1. Anybody have thought about this? Please tell. 2Q1 plus 3Q2 is equal to 300. First equation we got. Anybody to this? No doubt? Clear?
Yes, sir.
Understood? Okay. Now, similarly, we have to calculate second simultaneous equation. And for that, we have to use our first law of thermodynamics. That cyclic integral of dQ is equal to cyclic integral of dW. Or incoming is equal to, roughly, we can say, incoming is equal to outgoing. Okay. So therefore, by first law of thermodynamics, who will tell? Incoming is equal to outgoing. Observe and tell me. Incoming is equal to outgoing. So what is incoming to the engine? Now what is outgoing? Anybody? Diagram. I have schematic is with you in front of you. Incoming is how much? Which quantities are incoming quantities? There don't consider sign conventions. Only incoming is equal to outgoing. So Q1 is incoming. Q2 is incoming. Outgoing are, hello, Q3 and W. Okay, shall I write? Q1 means incoming is Q1 plus Q2 and is equal to Q3 plus W. So when we apply this law, incoming is equal to outgoing, there we should not use sign conventions. Okay, therefore Q1 is incoming before your diagram Q1 plus Q2 is equal to what is that? Q3 plus W. Q3 plus W. And these values of Q3 we are knowing. What is the value of Q3 now? Is equal to, therefore Q1 Q1 plus Q2 is equal to Q3 value. How much Q3? 50 kilowatt and 85 kilowatt. So I'll write summation 135 kilowatt. Correct na? 135 kilowatt is the answer. Now these two equations we got. So one is 2Q1 plus 3Q2 is equal to 300. Second equation is Q1 plus Q2 is equal to 135 kilowatt. So everybody understand? Understood? Okay. Now you solve equation number 1 and 2 and calculate value of Q1 and Q2.
Sir, Q1 is equal to 105.
Q1 is equal to 105. Everybody getting?
And Q2 is equal to 30.
Okay. And Q2 is equal to
30. 30.
30 kilowatt. Okay. Anybody? Okay. Ajit Gaikwad, Balaji Pise, okay, no problem. Ajit Gaikwad, Balaji Pise. So Q1 is coming as 105, Q2 is coming as 30. You can proceed for calculation of efficiency. Balaji Pise and tell me the efficiency also. So as other people, other students. Prashant Mali, no problem. Balaji, Ajit, Prashant. Bhaijan is there today. Bhaijan is there in lecture. Bhaijan. Today Suhas is not active. I don't know why. What happened to him. Rishikesh Deshmukh, same good. Prashant Mali, Rishikesh Deshmukh. Ah, so okay. Now efficiency, okay. Suhas is very active now. With efficiency, he got an answer. Given answer 0.63. 0.60. Okay. So Bhaijan is not here, sir. Okay, Ajit, good. Efficiency is 0.629. So Balaji PC efficiency is 62%. Correct. Balaji PC given answer for first previously. Correct. No problem. So efficiency is very simple. What is formula for efficiency? Here efficiency formula is what? Here eta He already given. Work obtained W divided by heat flood addition Q1 plus Q2. And Q1 plus Q2 we know that it is 135. So W is 85 kilowatt, I think. (85 divided by 135), and it is equal to 0.629. So they have not solved here. Write down. So 0.62 efficiency whole karke, very good. Prashant Mali efficiency is 0.629. Everybody efficiency coming at 0.629. So note down the problem. Write down. Those have not written. Write down. Such kind of numericals may ask for the examination. Again, we'll go for some tough numericals. Same numerical is here. This is solve. This is solve. Okay. Now this numerical. First day, when we have taken that heat engine, heat pump, on that I have solved, but I think I don't know whether I mean, how many of you understood. So this numerical will revise. The household refrigerator is maintained at temperature 2 degrees Celsius. Every time door is opened, warm material is placed inside, introducing an average 420 kilojoule, but making only a small change in the temperature of the refrigerator. Door is opened 20 times a day, and the refrigerator operates at 15% of its ideal COP. Cost of the work is 250 per kilowatt hour. What is the monthly bill of this refrigerator? The atmospheric temperature is 30 degrees Celsius. Okay. Now, time is less for us, so I will go fastly. So, household refrigerator is there. Maintain that temperature 2 degrees Celsius. Means its which temperature is given? Less. So, temperature is always sink temperature. Remember that. So, T2 is equal to, I will write here given. So, you write also numerical. T2 is equal to 2 degrees Celsius. 2 plus 273. Always we have to that temperature should be converted into Kelvin. So T2 for this refrigerator from which the heat is taken is 2 degrees Celsius, means here we can say it as a 275 Kelvin. Then warm material is placed inside, introducing an average of 420 kilojoule, but making only small change in the temperature of refrigerator. So this is what when we open the door, okay, what happens? This 420 kilojoule of heat is taking inside the refrigerator. Okay, so here Q2 means how much amount of heat is going into the refrigerator Q2 every time here 420, so it total will be how much 420 into, and that door is opened where by 20 times a day. Okay. And this Q2, this much amount of Q2 we have to take always, means we have to reject, we have to take to the source. Therefore, it will become 420. So this is what 84 8400 kilojoule of heat we have to remove from the refrigerator per day. Okay, that we have to calculate per day. Okay. Then here the door is open 20 times a day and the refrigerator operates at 50% of the ideal COP. And the cost of work, so power we have to calculate for the refrigerator. Okay. So here Q2 per day, and Q2 if we calculate similarly, Q2 if we calculate for per month, how much it will be? 8400 into 30. Totally equal how much is that? That we can calculate the Q2 amount. And the COP, the door is open, so refrigerator operates, COP of refrigerator will be, so here COP of refrigerator will be what? Will be what? 15%, means 0.15. 15% is what? 0.15 in COP ideal. Which is ideal COP? Who will take? Which is ideal COP for the refrigerator? This refrigerator. Which COP is ideal? Carnot. What is the Carnot refrigerator? It's COP because Carnot cycle is a ideal cycle. So Carnot COP. But what is Carnot COP? It depends on only temperature. Therefore, 0.15 into COP of refrigerator. What is the formula for COP of refrigerator? T2. We have to remember this formula. T2 divided by T1 minus T2. So T2 is 275. T1 is, how much T1 is there? Atmospheric. Here we are rejecting the heat. So T1 is equal to, T1 is equal to 30 plus 273 and is equal to 303 Kelvin. Okay. So ideal COP will become what? T2 275 divided by T1 minus T2 is, I think, 28. Okay. So is equal to what?
1.47.
Which answer is T1 upon T2 upon T1 minus T2. So total answer.
1.47.
Total. Multiply 0.15.
1.47. Yes,
Okay,
sir.
this is total. Okay. So this is totally 1.47. So
47.
COP of refrigerator is coming as what? 1.47. How I calculated? Ideal COP is 15%. Multiplied by 0.15. So 1.47 our COP of refrigerator. How much heat we have to reject? Total for month 8400 into 30. That is kilojoule per, we can say, month. Now COP of refrigerator is given by equation. What is the equation? Terms of heat ratio. Anybody? Refrigerator. COP of refrigerator is how much is there? Q2 divided by NC. Amount of heat taken divided by W. And this Q2 we are taking per month. W also we get per month. Therefore, W equal to is equal to Q2 is how much? 8400 divided by, here COP is 1.47. How much it is there? It is kilojoule month. Kilojoule per month. Anybody? 8400 into divided by 1.47. Help me in calculation. Anybody? Okay. So 8400 in divided by 1.47. Anybody? Okay. 5714. So 5714 5714 kilojoule per month. But they asked work rate is in 2.50 per kilowatt hour, means per unit, electrical unit, the work is 2.50. This is kilojoule per month. So kilojoule, okay. If I want, this is in terms of kilowatt hour, this quantity should be divided by 3600. So there will be work power is equal to, we can say, 5714 divided by 3600. How much it is coming? Anybody? 57 divided by 3600. It is 1.4 158 units. Okay. One point 50 minute and answer will be okay. And answer will be what? 250 point something is wrong in their calculation. So 1.50 into 2.5, that is the work rate. So it multiplied by 2.50, near about I think 3 point something where with the rate rupees.
सर
Multiply the rate.
हॅलो Q2 हा पर डेचा घ्यायचा आहे का मंथलीचा घ्यायचा?
Monthly ना monthly
पण
bill sign. What is monthly
Per
bill
day
for
बघा.
the
डेचा घेतला, एका दिवसाचा घेतलाय, त्यामुळे आन्सर चुकले.
कुठलं आपलं
8,400 आहे ते डेचा, त्याला गुणवले 30 करावं.
sorry. It should be month means sorry. It should be multiplied by 30 days. Okay, sorry. It should be multiplied by 30. It is W8400 into 30 into 1 point. So this should be multiplied by I think 30. Correct, na? Okay, and here also 30 means here it should be multiplied by 30. So what should be multiplied by 30? Sorry. So it should be 8400 into 30 divided by 1.47. 1.58 into 430. This will be units. How much units will be there? Anybody? Unit will be how much? How many units? 1.58 into 30. Only multiply by 30. Okay. How much units?
47.4.
41.4 units are there. And multiply by 2.50. So rupees in conversion rupees. How much rupees bill will be there for that refrigerator?
1,018.5.
No, 4.74 into 2. Rate is only 2.5.
118.5.
118.5 rupees. So this will be the monthly bill. So this kind of numericals ask for gate examination. No problem. In our case also they will ask such kind of numericals. 118.5 will be the bill. So note down this all things systematically. First step will be this step T1, T2. Then we can say Q2 how much is there per day, per month, 8400 into 30, okay, kilojoule per month. Then COP, refrigerator is equal to 0.50 into Carnot COP, 0.50 into T2. Carnot COP is T2 divided by T1 minus T2, it is equal to 1.47. Then COP is equal to Q2 divided by W per month we calculate. It's coming as what? 5714 into 30 divided by 3600 is equal to 1.58 into 30 units. Units will be 47.4 and monthly bill will be 118.5. Or somebody can calculate day bill, okay, day bill, per day bill, and afterwards per day bill is multiplied by here by monthly bill, and month we have to consider of 30 days. Generally, we monthly bill if after consider days are 30. Okay, shall we stop today here? Shall we stop? Conclude?
Yes, sir.
Shall we conclude?
Okay, sir.
Yes.
Yes, sir. So mention your attendance, roll numbers, and roll numbers, first roll number, and your name, and queue the class.